Water storages are subject to seasonal influences that may affect water quality. When water storages become out of balance, algal blooms and surface weed infestations develop rapidly, requiring labour and financial resources to restore the water quality back to a natural balance. When water quality declines, filtration and intake foot valves may require additional backwashing or cleaning, and irrigation equipment such as solenoids and emitters can become clogged or behave erratically, with the potential to affect production. Wastewater entering a water storage may be contaminated with organic matter, nutrients, and sediment. Organic matter can be dissolved in the water or be solid particles such as growing media, both of which consume oxygen. Sediments can settle on the bottom of storages, acting as a store for nutrients and leading to low levels of dissolved oxygen. Nutrients provide food for the various forms of algae and promote biological growth, which consumes oxygen when it decomposes. Algae are free-floating plants that are normal and essential inhabitants of sunlit surface waters. Algae can affect water quality and become a significant management issue if their growth becomes excessive. Algae in water storages are classified into three forms: planktonic, filamentous, and macroalgae. Planktonic algae are microscopic plants floating in the upper 60 to 90 centimetres of the water column where sunlight penetrates, and are an essential part of the food chain in a healthy water storage. Temperature, light, wind, and nutrient levels influence the growth of planktonic algae, causing algal blooms that colour the water varying shades of green, blue-green, red, or brown. The natural decline of algal blooms during cooler weather conditions results in depletion in oxygen levels. Some forms of planktonic algae can be toxic to animals and humans and produce unpleasant odours. Filamentous algae are made of single-celled organisms, joined end-to-end to form thread-like chains or filaments. This type of algae grows along the bottom of the storage in relatively shallow areas, then floats to the surface due to oxygen production, forming floating mats on the water surface. Filamentous algae are harmless and non-toxic, and have a texture that may seem cottony and slimy. Macroalgae, also known as stoneworts, are branch-type algae that are visible to the human eye. This form of algae is attached to the bottom of the storage in depths of 1 to 6 metres and can often crowd out other aquatic plant species. Mats of macroalgae have a wiry, coarse texture along with a fishy odour. Duckweed and azolla are common free-floating aquatic weeds and are usually a sign of high nutrient loads and can lead to organic sedimentation and build-up on the bottom of the storage. Duckweed appears as a green cover on the water surface, growing rapidly in nutrient-rich stationary water bodies and can double in numbers in 5 to 7 days. Azolla appears as a green or reddish cover and has fern-like leaf appearance with roots trailing below the water surface. Azolla can double in numbers in 7 days. Managing water quality in water storages is best achieved by preventing water quality issues from becoming extreme, with early intervention the best management technique. Regularly monitor water quality, reduce nutrient levels, limit organic material in wastewater, and provide some level of mechanical aeration. A combination of physical removal or chemical treatment of water weeds, aeration and circulation of the water body, and the addition of microbial products can be used in an integrated approach to managing water quality issues. Physical removal of floating water weeds, filamentous and macroalgae, partnered with chemical treatments, can support the addition of biologicals in storages containing extreme algae and surface weed growths. On their own, these methods only treat the symptom and not the cause, and often lead to problems from dying and decaying vegetative material, further reducing oxygen levels in the water. Aeration and circulation of the water body can assist in maintaining a stable pH and preventing stratification or temperature layering of the water, providing healthy and biologically active water. The addition of concentrated microbial products containing various bacterial bacillus strains can improve water clarity and quality, reduce ammonia, nitrate and phosphorus levels, control methane and sulfide odours, and reduce sludge and organic sediment. Further information on water storages can be found in the publication Managing Water in Plant Nurseries. This video has been supported by the Queensland Government Department of Natural Resources and Mines under the Rural Water Use Efficiency Irrigation Futures Initiative. Special thanks go to the following businesses for their assistance in producing this video.